So this afternoon we will deliver our material. So my name is Muhammad Arifin from Polibatam, and also Mr. Soh Kim Phai from Singapore Polytechnic. So this afternoon we will to share our activity this year, last year, and this year. So with the title Transnational Interdisciplinary PBL using the CDIO framework, opportunities and challenges. Yeah, okay, maybe I think you know about it. So this is a CDIO, conceive, design, implement, operate. So we encourage our students to conduct the conceive stage. We bring our student to the village or to the stakeholders, yeah, especially for the community or social project, and they looking for and ask to the stakeholder to looking for some problems. So we call the conceive stage, and then they make some solution ideas, and then after the conceive continue to the design. So the design, our students can use the tools that related with the design. For example, for mechanical, so maybe students can use the AutoCAD or maybe SolidWorks and other tools, and electrical using like the Lithium and other software. So I think this is just skills that we would like to support, yeah, to encourage our student to develop this skill through this stage like this one. So after the idea, so we our students choose the potential idea to be make a proper design using this stage, and then they conduct the design. After the design is okay, so they continue to the implement for manufacturing product, and like coding, testing, and validation, and etc. So I think the interpersonal skill is important here. So like teamwork, communication in English, because the project already conducted with the different students. Yeah, different students. Student from Polibatam and also the Singapore Polytechnic. So in Polibatam, we collaborate not only in one study program. We collaborate from a student from the electrical engineering and mechatronic engineering, and also the media program and business program. So we collaborate with the student from Singapore Polytechnic in mechanical engineering. Yeah, okay, I think the interpersonal skill is important. And then after implement, we continue to operate. So our product, we deliver to the village or user. So we need the feedback for the user. Product is okay or no. If the product is no, not okay, as the requirement from the stakeholder, we try to conceive again. So this is like a cycle. Yeah. Next, Mr. Soh. Yeah.
Can hear me, right? Yeah. For recording purposes. Okay, good. Now, CDIO is a great tool, is a great framework for us to organize ourselves when it comes to project. Here, we're trying to stretch our limit a little bit by having a transnational collaboration, whereby I think resource is much needed, and then we're going to collaborate, overseas, and sometimes we just cannot have face-to-face meeting together. So we are stretching ourselves a little bit to try out this transnational and transdiscipline kind of international collaboration. So essentially, CDIO we find so neat because with this CDIO is basically a product creation process. We use this to design our Gantt charts, the way we want to achieve at different stage is CDIO. And different stage, we have different outcome. So basically, C is what I want to do. No constraint. Understand the needs of customer. D is what I can do. Because what you want to do may not possible to be done due to state of arts, due to the regulatory requirement, many constraints. So what I want to do, what you can do, okay, and what we're going to do. And finally, we deliver the value, the solution to the stakeholders. So this is essentially the idea behind. So CDIO is a great tool to plan, and CDIO enable us to divert. Sometimes we are prepared that Batam Poly student will have a different solution than Singapore Polytechnic student. So it's okay, because at the end, we might deliver more than one solution to the stakeholder. Okay, but we try to converge every time we meet, divert, converge, divert. But the outcome in our trial so far is that we managed to convert to a final solution. So there is a good portion of work involved, because happen that your student is more on the mechatronics side, so they handle the electrical circuitry design part of things, and we also want them to design the base. Whereas my student coming from the mechanical engineering, so we want them to design, focus more on the mechanism part of it. So this is a project whereby they're supposed to slice the banana to a certain thickness. So that mechanism, basically our student will handle that. So from design all the way to fabrication. And at some point, they bring all the their innovation together, and then they assemble together. Hence, there must be some face-to-face meeting. As much as we would like to have an online meeting because it's more cost-effective, but there must be touch point, face-to-face touch point. So in our experience, the best touch point is during the conceive stage or before that. They must be together, okay, to know one another better, and better still, they should do the design thinking together. Design thinking basically is to uncover the unmet needs of the stakeholder. So they should do it together. Unfortunately, which is a challenge that we face, the academic calendar is different. So how do we handle all these things? So we can talk about that. So basically, this is the flow of the activities. I think you all can have the slide. So it's quite a common sense, but because they understand that different stage, they should have a different mindset. Like what I mentioned, what I want to do, what I can do, what I'm going to do, what are the method to produce a part. So their mind basically switch from stage to stage. So that is a very important part of CDIO. So I think with that, we'll go to the next slide. Okay.
Yeah. Okay. So I can continue about the presentation. So we try to integrate some courses to build some skills like this one. So this is courses. So we just choose some courses. So like this one, this is from the instrumentation engineering, like the analog electronics and measurement and calibration, and also from mechatronic, like computer numerical control and others. So this is from Singapore Polytechnic, like a capstone project. So the color is it means they support like the skills. For example, so the capstone project and project courses we have in Polibatam, we have the special courses for the project every semester in certain study programs. So like this one, so like we would like to develop like the teamwork skills, communication skills in English and Indonesia. And also this is mechanical design and mechanical fabrication using mechanical tools. So like this one, so like the for electrical, these skills supported by this course. This is just for example. So actually we have the several some courses. Maybe I don't mention here because it's just a presentation. So like this one. So to build this product, we need to this skill like the electrical and electronic design and fabrication. So we need to give some material to our students to guide them they have to know, they have to have the skill. So we need to do some courses like this one, analog electronics, and also the basic electrical engineering maybe. So and then for measurement and calibration, so this is courses that supported these skills to build this product and etc. So we actually we meet in person with the Singapore Polytechnic students twice per semester, twice in person. But we I think they often discuss by online. So I think it's important because if we often the in-person meeting, so I think we have the challenge in budget maybe. Yeah, maybe, and maybe the and other regulation. So for me, so uh, now for especially for the project, all students from Singapore Polytechnic come here. But from me, from us, from Polibatam is never go there. So maybe yeah, because the yeah, but the actually the project is work here. But maybe the next we will try. So in our Polibatam, sometimes we have the challenges about the budget. Yeah, this is our challenges.
And because the problem is in Batam, rightfully the host country should do the fabrication.
Yeah.
That will be easier.
Yeah.
Because I do face some challenges bring the hardware over.
Oh yeah.
I do have some problem with that. So.
Yeah. Okay, so sometimes we have challenges, another challenges like the product or maybe tools. So sometimes we have the problems in immigration. So sometimes So I think this is our challenge. I think it's important for us as a suggestion for the next collaboration. So this is a final project like this one. This is our target. So the product or this project, the result or output this project is we need to the other skills, not only the disciplinary skill, but we need to the personals, interpersonals, and also like product development skill also. So about the standard, so we know the normally standard CDIO is there are 12 standards. Standard 1 starting from the context until the standard 12. Evaluation program. And there are still 4 optional standards. So I think this activity that we collaborate with the Singapore Polytechnic, this is relevant to the optional standard 1 about the sustainable development. And then the optional standard 4 about the internalization and mobility. So if you check in the CDIO.org, so you can find this optional. There are 4 optional standards. So I think important to guide us. If we know what the level we achieve now, we can use the rubric there. Yeah, I think the rubric can guide us to. So I think start from the 0 to the 5. I think that each standard there are some rubrics. Yeah, I think continue.
Next slide. Yeah. So I mean, this is a typical example of integrated curriculum.
Oh yeah, video.
Oh yeah. Hang on. So there are many strategy in doing integrated curriculum. I think one of the popular method that I use is to have what we call the bus. Bus means your different courses can hop on to at any point in time to contribute the education element in the projects. So imagine you have 1 semester to do a project to be delivered at the end of semester. So you can invite a few courses to participate. Okay, at different stage of, they can run their courses parallelly, but at different stage they can contribute to the project. So this is a very effective method that I use in many of our cornerstone project. Yeah. This one is not. This one is happen to be a final year project. Yes. So your kind of target can also be achieved if you want to have project-based course that can be designed. Could be mini project. If you want to have a cornerstone project, and I mentioned before, every stage of the students' development should have a cornerstone project that culminate into a final year project. So if you want to have that cornerstone project, then advisable to have integrated curriculum. Get more courses come together to share the resource. Okay. Yeah.
Yeah. Next, we
This is a video.
show about the video. There's I think just a 3 minute short video.
Is home to several leading universities, including Batam State Polytechnic, which plays a key role in producing highly skilled professionals. Batam State Polytechnic equips students with practical skills and global competitiveness through hands-on learning. Batam State Polytechnic is currently collaborating with Singapore Polytechnic to develop a banana flipping machine. In the conceive stage, students and lecturers gather in a meeting to exchange ideas, create sketches, and develop the initial concept of the banana slice machine. Joined by students and lecturers from Singapore Polytechnic, actively participating in the banana slice machine project. In the design stage, students transform their ideas into technical plans. They create 3D models, determine dimensions, play placement, and design mechanisms to ensure the banana slicing machine operates efficiently and safely. In the implement stage, students begin turning their design into physical products. They cut, assemble, and install each component, ensuring the banana slicing machine functions exactly as needed. Before moving on to the operate stage, it's worth noticing that the banana slicing machine project began last year. It was unsuccessful. This year, with improved designs and strong collaboration with Singapore Polytechnic, it has shown remarkable progress. In the operate stage, students run the banana slicing machines that they have built. They have tested the performance, evaluate the results, and ensure the machine is ready for optimal use. The collaboration between Batam State Polytechnic and Singapore Polytechnic demonstrates that cross-border partnership can bring forth innovation that benefits society.
The good thing is that both our institution has our project funds, so together we can do much more. So that's what we find the opportunity aspect. There are challenges, but there are opportunity as well. Most important is that we want students from various countries to have an opportunity to network. That is an important learning outcome. Whether the project is successful or not is another matters. But they work together for 22 weeks. I thought they have certain rapport and then they build network. That's more important, especially ASEAN student from the ASEAN countries.
Yeah. Okay. Next, Pak Sof will deliver about the feedback.
This is the feedback. Basically, essentially, in terms of the effectiveness of feedback on the teamwork and the communication, I think student seems to give us a lot of feedback for such an arrangement, such a program. And in terms of challenges they face while working remotely, we try our best to meet face to face, but we only have 4 milestones. We use CDIO as a milestone meeting. to confirm what they have done so far. So two online meeting and two face-to-face meeting. In fact, online meeting we have more. On a need basis, we need to have more. And seems from the student perspective, the language barrier seems to be one of the key issue. When we say language, doesn't mean just the speaking language, but sometimes they get the message across wrongly, because when they communicate over Zoom, for instance, their idea kind of being filtered off in a off tangent way, and the student on the other side get it wrong. Okay, and one of the important lesson we learn is that the student at the conceive stage is needed to get it right. If they don't get it right, subsequently design, implement is going to be wrong anyway. That's why our first attempt is wrong. One of the funny thing that the student, including me from Singapore, we don't know the raw bananas is so hard. Okay, they need hard banana for slicing. So we do have raw banana in Singapore, but not as hard as in Indonesia. So it's really very hard, and then not strong enough to cut. So we drop that simple idea and we use a more rigorous approach. Okay, so language barrier, as much as we would like to harness technology, but they still like face-to-face. I thought education is a very social service, right? Social service. So I think human bonding is important. Face-to-face is still very important. Okay. And in terms of collaboration, I think they feel that the way we arrange in phases, the feedback is quite favorable. And we were quite surprised because they come from different culture. My student from Singapore, one from Myanmar, one from Malaysia, and one from India. I happen to have three, so it's multinational. But apparently, when youngsters come together, cultural difference, I think generally is okay for them. Okay, and we ask them what to improve further. Most of them still say face to face. Okay, so to the youngsters, I think this is very true. Human, we just cannot just go to Zoom and then we create a rapport, right? We need face to face, like this kind of meeting. Okay, that's important. Okay, so key insight is that we find from international collaboration, language barrier, lack of face-to-face is still very important. We have to design some face-to-face touch point at some point, and time zone. Sometimes we forgot that we are ahead of Batam 1 hour, and simple things like that. Sometimes we get it. When to meet, things like that, we get it wrong. Okay. So despite challenges, the majority of students feel that the written communication and overall teamwork effectiveness, well, because it's guided by the CDIO framework. Okay, so the framework is very logical way to design your timeline. And the teams are generally able to overcome barriers and collaborate successfully. I feel that I give credit to the framework as well. It's not that we design something based on our experience. We have a logical framework to do the planning. Suggest improvement. Quality in-person meeting is what they ask for, but sometimes not affordable because we also have budget. Okay, highlighting the value of direct interaction for building trust. This one means at the initial stage, we have to make sure the stakeholder understand the needs, okay, that the student is coming up. So once that is being locked into, the rest of the process is much smoother that way. Okay, and that's why I need to emphasize the design thinking process. So C and small d is basically design thinking. Okay, that's all I want to say. Next, we have a hands-on session for active learning. So go to the next slide, please. Okay, so I hope we have time. Now, as I mentioned before, such a learning experience typically is 3 hours. I run this course before, and including come up with some low resolution prototype using crafting material. Okay, but we know that we don't have enough time. I just want you to get the idea of such a learning experience. Basically, I'm going to share with you the importance of design thinking, because in 2024 we get the idea wrong, and then we just keep on designing, we keep on fabricating, and then we deliver to the villagers and they say this is not what we want. Okay, so we learn our lesson. The next run we basically are mindful to check with the stakeholder, is this what you want? She said yes, then we design. And before we fabricate, we also go back to her again, because once we finalize the ideas, we have to double check. So this is what she wants, and I think after this meeting, they are going to deliver to the villagers. Probably will get it right. Okay, so I'm just going to emphasize the importance of getting the needs of the stakeholder correct in the first place, right? So I'm going to give you a simple case study. Now, this is a real case study in Thailand. In Thailand, they have this particular village, and whereby the water is very murky, and they want to use it for drinking. So therefore, they need to pump it up and then filter it off before they can drink. Otherwise, they have to use rain. They need to collect rainwater for consumption purposes. The children also don't have much entertainment, so there is this need to purify the water from the pond and to promote communal activity. So one of the way, of course, is to have look at the redwoods and fun. Okay, to promote fun and communal activities within this small little zone over here. Yeah, this pond plan view, top view is something like that. Okay, so they identify perhaps some fitness corner over here. Okay, so what I want you to do now, based on the needs of the stakeholder, on your own cluster, if your cluster has too many people already, you may want to join another table. I can only afford you to have at most 10 minutes to think of way, okay, how to have fun, design a simple playground, and they're able to, at the same time as they play, pump water out to filter. Do not be worried that, hey, I'm not from the engineering the school or discipline. Do not worry, because at the conceive stage, usually the business student, based on my experience, they are very good, because engineering students, the problem is that they would think, this is not possible. They know too much already. Okay, in conceive stage, you have to be a bit naive. Remember, I said conceive is what you want to do. Design is what you can do. Okay, implementation is what you're going to do, what method. Okay, and O is you deliver the value to the customer. Okay, so with this need, can I ask you to, within 10 minutes, try to think of a system. I do not have crafting material for you like what I've done for my student, but you can just sketch it out using the this. We'll provide this paper. Okay, but you discuss first, and then you sketch out a simple drawing which I may not understand. That's why you need to stand up and present your case. Okay, I will probably select one or two in view of time. But okay, now why I need 3 hours actually, because in my class, I also have to talk about how to select concept, and how to translate your concept into engineering specification. So this one I'll just ignore for the time being. Is for your information. Okay, because customer can say, I want it to be strong. Engineer will say, how strong is strong? right? So we had to teach that as well. So these are the tools. But for now, we just focus on the idea. Okay, on the idea. To save you time, I already highlight to you the needs of the customer is to purify the water from the pond. So you need to pump up, and then they need to have a playground. Can we integrate them together, playground, and they will have fun, okay, and then to promote communal activities within this region, okay. So I briefly give you the problem statement already. In real life, the student have to go to on site to discover this problem statement. That's why I highly encourage you to join our Learning Express. Okay, 10 to 15 minutes at most. Then I will ask some of you to stand up to present. There's no right or wrong answer in the conceive stage, but in the design is a totally different ball game. Hello, now there's no need for you to fabricate the prototype. You just sketch out the prototype will do. Okay, so of course in my class where I have enough time, 3 hours or even 4 hours, they are supposed to make a low resolution prototype using crafting material, cardboard, things like that, glue, but we can't afford that. Okay, you just sketch out your ideas. So it's well, sketching is also part of prototyping. Mm. So I would expect different ideas from the same problem statement. So it's a playground. So when the children having fun, they also help the community by pumping water out to filter the murky water into something that is drinkable. Yeah, I heard someone mention about material. Now in this village, there's abundance of bamboo, PVC pipe, steel, no problem. When I bring students to village, I observe what are the material available, what are the skills of the local community. So in that way, the solution will be something that they can help themselves at the end of the solutioning. Okay. Yes. Small D. Yeah, yeah, no, no. Final year project, you have, our student have 22 weeks. Yeah. Uh, I think it's good for you to start sketching now. Now, I'm sorry that I did rush you a little bit, um, but it's just an idea. Knowing that in our actual setting, our students have 22 weeks to do a project. Here, I just want you to have some ideas, impression about how we go about, facilitating this kind of project-based learning. Okay, probably in the 2 minutes time, I will select one of the team to present their ideas. Uh, you you don't have to be too technical at this point because we are not going after the details. Just to have initial ideas, pretending that I'm the stakeholder. I will see whether it's something that I need or not. It's about addressing the needs of the user, not so much on the technicalities of things at this point in time. Huh? It must meet the needs of the user. We have one team ready. This team comprises of two lady. It shows that number doesn't matter. Huh? Okay. Okay, okay. Hi, all participants. In view of time, I'll just appoint one group to present. Okay. Because I probably would not understand your sketch. That's why I prefer students to build something out as a prototype. Yeah, can I have your attention to let her present? Yeah. Okay, guys. Guys, we really have to stop now. I'm sure you have a lot of brilliant idea. That will happen to your student as well because once they get engaged, you cannot stop them. But I have to stop you now. Yeah, yeah, I have to stop now. I will. I think there's a lot of brilliant idea as well, but I have to pick the one that finished first. Okay, I'm sorry about that. So she will now talk about her ideas that will address the needs. I'm the stakeholder. I will see whether is it okay or not. You just present here, or you can come up. Okay. So very quickly they sketch out something. At this stage, it's just the idea. There's no right or wrong. I think.
Thank you. So, good afternoon to all of you. So, I'm Aina from Malaysia, and also this one, my colleague Siti from Selayang. Okay. So actually, it's just a rough idea from us. We are focusing on the what we call that challenges for the villages. So the first one is the water to purify the water and also to promote communal activities around the reservoir. So our suggestion is the first one is to purify the water. We suggest like we have here fitness corner, but we have the pedal pump so they can exercise too there, and also we have the water wheel. That water come to we want to filter the water using the charcoal because charcoal is so low cost, because we have to think about this is a villages, they don't have any enough money, something like that. So the water will go to the villages to the house, and also the pure water, the filtered water can be used for the person or any individual that use that. We propose also the jogging path there. So after the jogging, they're thirsty, so they can drink that water, something like that. Okay, the other one is we also suggested, because one of the what we call that action that we can use to purify the water is we put the fish. There are some of the fish can be used to make the water clean, such as we call in Malaysia is bandaraya ikan bandaraya, so like that. The aquarium fish, is it? Okay, so they can use that and make activities for fishing also there, and also for their income. Okay, do you have any? Say. Okay, thank you from us.
Now, in fact, I overheard this group saying they want to design something that encourage people to jump, right? Now, how does jumping translate into the pumping of water? That's quite interesting. So, we are not saying right or wrong at this point in time, but you can hear that they want to have charcoal filter, some wheel, and with a pedal pump. So, all these things, how to put together, that will be the next stage of the project. But at the conceive stage, we want to look into the addressing of the needs of the user. If even at that stage, it doesn't address my needs, then whatever you do down the road is a waste of time or effort or resource. So that's something that we want to share with you. And finally, as you can see, CDIO is a very good framework for you to do your planning in terms of timeline or in terms of what you want to do at various stage of your project creation. Okay, with that, thank you very much.
Okay. Thank you, Mr. Soakim Fai. So I think this is a final session for us. So thank you for your attention. So we need to next session. Dr. Rajeev.
you like this kind of template, you can use it as a template, redesign to suit your local context.
Good and good afternoon. Yeah. Just before we start, I'm Rajeev and this is Christhu. I'm also the Vice Chair for Teaching and Education in the United Nations SDG 4 Quality Education Hub. So my role is also to, ensure quality education, which is one of the UN's very important agenda. So across the globe, we also interact with a lot of institutions in terms of improving the quality of education. So that is one of my major roles. Meanwhile, I'm the Director of Learning and Development at SRM Institute of Science and Technology in India. And we have the head of learning initiatives, academic learning initiatives, Dr. Christhu. So we are here to discuss a few elements related to, higher education space. Especially context is to India, and then it may be applicable to you as well. So let us first, before we start, I want to play a quick video about the institution where I represent. So it's just a quick video.
A legacy in education and enlightening lives that spans 37 years, led by a vision to build a nurturing academic environment. SRM Institute of Science and Technology stands at the forefront of India's education revolution. Welcome to India's finest multidisciplinary university that has won national and international recognition. Spread over 400 acres, SRM IST functions from 5 beautiful green campuses at Kadangulathur, Ramapuram, Vadapalani, and Trichy in Tamil Nadu, and at Modi Nagar adjacent to New Delhi. Together they offer a wide range of undergraduate, postgraduate, and doctoral programs in over 100 disciplines. Over 50,000 students from around the world pursue academic programs in 6 faculties: agricultural sciences, engineering and technology, medicine and health sciences, law, management, and science and humanities. A highly accomplished faculty with the perfect blend of teaching and industry experience provides students the best guidance and mentorship. SRM IST is replete with all the facilities that a student would need, from a huge aircraft hangar for the students of aerospace engineering to one of the finest medical simulation centers for students of medicine. Every discipline of study has specialized labs with state-of-the-art equipment. In addition to individual department or college libraries, a digitally enhanced, well-stocked central library houses over 3 lakh books, 40,000 e-books and journals. In an increasingly interconnected world, SRM IST understands the importance of collaboration and has signed a number of MOUs with leading institutions and universities abroad for faculty, student exchange, and research programs. SRM IST, boundaries of knowledge are constantly pushed, encouraging research in every discipline of study. Centers of excellence with well-funded R&D facilities, functioning in association with industry, the government, and private agencies, make SRM IST a premier destination for researchers. Each and every SRM student is groomed to hit the ground running when starting a career. Last year, more than 1,000 companies visited SRM Institute of Science and Technology and made over 12,000 job offers, with a compensation package reaching as high as rupees 1 crore per annum.
About 400 students have been participating in international competitions where they need to design, develop, and demonstrate their products. Fab Lab has a state-of-the-art equipments where precocious projects can be engineered into reality, realize and achieve their dreams together.
Welcome to the Fab Lab. This is where we introduce you to your new partner in your innovation, the machines, which works 24/7, 365 days for you. If you have some idea, you feel the world should use it, this is the way you should build it. So what are you waiting for? Let's get into it. The idea of creating a single multi-purpose workspace for all engineering students has come to us in year, and that's when the Fab Lab started. It took 2 years to build it, and now we have inaugurated the Fab Lab in this year. Fab Lab is spread all across 20,000 square feet and 6,000 square feet build area. Fab Lab is equipped with 30 plus heavy duty machineries, 100 plus small machines, and thousands of consumables and inventory items.
Besides placement, the entrepreneurial skills among students and faculty are identified by the SRM Innovation and Incubation Center, SIIC, which eases their startup journey through Indus' beautiful lush green campuses, have conveniences and facilities around every corner.
Just to get you an idea about the institution that we are talking about. So we have more than 60,000 students in one of these campuses, and have around 4,800 faculty members. So you can imagine the scale of operations that we are addressing. And we have implemented CDIO. So let us quickly go through the journey in which we went into CDIO. 2017, we were aware about CDIO. And one important aspect that we did during that time is to, in order to run CDIO across the spectrum of our university, we need to have an exclusive learning and development center, and that's where we are working from. So 17, we were well aware of about CDIO. And even before that, we were using another curricular design model called as the ADDIE model: analyze, design, develop, implement, evaluate. ADDIE is a very much a known model to everyone because it was originated 1960s or so from the US Navy. And then we built the Fab Lab. The Fab Lab that was shown to you was built, not only the Fab Lab, we also built the Innovation Lab and the Technology Lab to associate with it, because fabrication is part of, innovation, fabrication, technology, incubation. So it has to go in tandem. So we had to build all the three labs. Fabrication facility was one, innovation lab was the other, the technology was the other one. So after these were built, then we started introducing in the first year, like CDIO recommends to use a first year program called as Introduction to Engineering. but rather what we introduced was introduction to the, philosophy of engineering was a program that we introduced right in the first year. We wanted to slightly scale a little higher. So we called it as philosophy of engineering, not just introduction to engineering. Philosophy engineering also addresses the questions of, methodology, ontology, axiology, etc. So then we also started giving projects right from first year till final year. Whichever course they are going through, every 2 course, 3 course combined together, they will have to do some projects. No matter what, projects are integrated into the curricula itself. So that means part of the curricula is to create projects, case studies, innovations, anything connected with sustainability, we have to do it there. And in the year 4, that is only even though 2017, we knew about CDIO to get things built and put it into realistic place. Only after that we applied for membership. We could have applied it in the very next, we didn't do it. The very purpose is to implement things and then apply for a member. Why I'm telling this is to all the new members who aspire to be members, it's not just getting a membership shown in the map that is not going to help. What you do internally is actually help. So we were not very curious about becoming a member, but we wanted to, in principle, put everything into practice and then become a member. So that's why we became a member, not only of CDIO. All our curricula is designed around 3 aspects. All our curricula is TPAC curricula. It's from the Arizona State University. Technology, pedagogy, and content knowledge. That means earlier our syllabus was talking only about content. Now we also talk about technology and pedagogy for that content. So that's how the curricula has been designed. So all our curricula is CDIO, TPAC, and we have also introduced the very famous Purdue University model called as the EPICS model, Engineering Projects in Community Services. That means any project that you do in while studying or for your capstone project, all those projects have to serve the community. So we tied up with Purdue University and adapted their social engineering curricula and custom design it to our requirements. This is what we did in the 2020. Then subsequently what we did is that after we found success with engineering programs, we just expanded it for science programs, humanities program, and a management program. In other words, you can also understand that like we had a philosophy of engineering, we have philosophy of management, philosophy of science, philosophy of humanities, as the case may be. So we introduced it into these 3 schools as well. And then subsequently what we started doing is that we started introducing it to the medical education as well. Medical education is not just outcome skill based education, it is a competence based education. We cannot produce a medical doctor who is competent to go and do a heart surgery in the field, am I right? So we followed the competency medical model. So for that competency model, we took the best practices from CDIO and introduced it there as well. Similarly, we also were running the agricultural degree program, so we did it there as well. And subsequently in 23-24, that is last year, we went and showcased all these things to the United Nations Academic Impact. And that is the reason why I am the vice chair for the next 2 years. Are you able to understand what I am trying to say? Because when we do something which is focusing towards sustainability, you also focus it. And we are very much a part of SDSN. SDSN means Sustainable Development Solutions Network. Find solutions to sustain in this planet. I am sure all our institutions can become a member of UNA as well as SDSN and contribute for a much larger cause. And last year we were very specific. We had other group of institutions. Apart from the university that I talked about, we also have other engineering colleges. The same group of education institutions has other colleges also. So we are now expanding the CDIO to our group institution. That is the target for this year. So this is the scale at which we are. Now let me go a little specific about one of our government's regulatory body, which is called University Grants Commission in India. UGC suggests for any full-time degree program, 40% of the courses can be provided completely online. Okay. That means you have to also understand that most of the courses have to have simulations, emulations, and things like that, or full infrastructure facility where you can push 40% of the courses. So in India, we follow four-year 180 credits. Every semester is 20 credits roughly. So for a 4-year degree program, you have to achieve 160 credits, out of which if you take 40 credits, that means 64 credits can be completely done by the learner or the student in online mode. Okay. And for the remaining 60%, courses can be offered. For example, 30% of the courses can be in 50% online content. That means some physical interaction and some online content. And 30% of the courses can have 40% online content. Sooner or later, what is happening is that all our courses and materials have to go into some digital form. Even actions, the methodology and the pedagogy has to go into a online mode, and that is where our real challenges came. Just to get you an idea about how the credits are, if after a student finishing school and joining the undergraduate study, every semester is like 20 credits. So at the end of first year, assume a student wants to leave the college, okay, due to whatever reason. If the student wants to leave a college, we still give a 4-credit skill certificate and he will get a undergraduate certificate, not a degree, undergraduate certificate. So when he goes to the next year, that is second year, and the student suddenly wants to leave the organization, leave the institution, and due to whatever reason, he wants to leave the college and go, that time he will get a diploma. Even though we have separate polytechnics in India, even in our engineering institutions, we have given an idea that they will get something like a skill certificate. We call it as ITI or skill certification. That is something which you will get. Second year, if he wants to leave the institution and go out, he can still get a diploma. Okay, I left because of some family pressures, or I didn't have enough funding or something. I want to leave. So I left with a diploma. Okay. Then I'm working in somewhere in the industry. Now I have little more finance. Can I come back and study? Yes. You can come back and again join for the second year and continue your study towards your third year, where you'll get your science degree program. Got it? So third year, somebody gets a, for example, Bachelor of Science in Electronics. You'll get a Bachelor of Science in Electronics. Suppose you continue to the fourth year, because all our, you get a, either there are options, Bachelor of Science in Electronics with honors in certain area, or you can get, if you have done research courses in this period, you will get a UG research degree, or you get a Bachelor of Engineering or Bachelor of Technology degree. Okay. Or after this, you want to get a PG diploma, appropriate. So appropriate things you can choose and study. So this flexibility has brought in a lot of trend in terms of students. They can go out, come back, continue their study. Then if you move one more year, you get your PG degree, postgraduate degree. PG, UG is undergraduate, PG is postgraduate. In other words, in America, it's called just graduate degree. Okay. Yeah, we call it postgraduate degree, I don't know. Okay, so it's like this, 4 years, 160 credits, and as you move further, you can also. Wherever I'm saying, you see NCRF, it's called as the National Credit Framework. We have a credit framework. Based on that credit framework, as you move year after year, you also get your degree. So this is the infrastructure, this is the planning structure for a degree program. I go a little further and say, for a 4-year degree program, somebody has to do 160 credits. Okay. Somebody joined mechanical engineering, and he, in 4 years, he is supposed to get 160 degree. Now that mechanical engineering student, what he or she can do is, I just split it into two, 50% here, 50% here. I'll tell you what this is. 50%, that is this 80 credits courses, will be only on the core mechanical engineering. I repeat again, this 80 credits will be only on the core mechanical engineering. What about this 80 credits? What about this 80 credits? It is purely the choice of the student. It's purely the choice of the student what courses he wants to do. For example, let me give you 2 examples. One example, somehow I joined mechanical engineering, but I'm not very keen about mechanical engineering. I still want to do some other courses. Very good, register and do courses here. These 80 credits, but put together there should be 160 credits to get your degree.
So this 80 credits, for example, I'm studying everything about film, technology, animation, direction, acting, drawing, dancing, everything. Yes. But all those credits have to be properly, a course should be there, evaluation should be there, and you can earn it. So can I specialize on something else? Yes. Let's take another example, another extreme case. I am a die-hard mechanical engineering fan. This 80 credits also mechanical, either way you have to do it. This 80 credits also, I'll study all advanced mechanical courses. Yes, permitted to do so. So 50% of your degree program, the student decides. 50% of your degree program, the student decides what he wants to learn. That means from a pool of baskets of courses, he can pick, okay, maybe I'll study 2 foreign languages. Maybe I'll study some humanities courses. Maybe I study some art courses. Maybe I study some, computer engineering courses, which doesn't need much of a prerequisite like coding course or something like that. That means the student has a complete freedom to work around. And our system is generally like this, like every semester you have to take 20 credits, and this is roughly the structure, but a lot of alterations can be made on this. This is just to give you an idea about how we are running or designed our degree programs. I'll just go to the next slide. Okay. There is yet another way of offering the, see, curricula once it is designed. Okay. Evaluation is also standard. Whether you do your program in regular full-time in-class mode or whether you study in part-time mode, that means evening college or come in the evening and study, or whether you offer certain programs on distance education mode or you study in online mode, same curricula standard is maintained. Curricula standard is maintained as the same. So there isn't any difference whether you study whether online, regular class, distance. Can I blend and take my program? Yes, some courses you can take it online, some courses you can go into part-time mode, some courses you can. That means across the university there are online, distance, regular classes keeping on happening on various aspects. Certain courses cannot be completely done online where you need heavy machinery and things like that. Those programs will be offered in the regular mode where you have to go and actually operate the machinery. Something which can be simulated, emulated, you can always do. Another important aspect the government is pushing here is the skilling program. That program is called Skill India. Under this, industries welcome engineering students to do internship for 1.5 years, that is 3 semesters. So if I register for a 4-year degree program, 1.5 years I can go to the industry, be in the industry only, no other course from the college or from the university. 1.5 years I can be in the industry, practice with industrial guidance, and even earn stipend, money stipend, I can still earn. Then I come back and get my degree as well. So it's these flexibilities are given. Now addressing why we are doing, I'm sorry, we were, okay. Now coming to child learning and adult learning. Child learning is what is called pedagogy, but Malcolm now brought in a term called andragogy. So andragogy is very popular nowadays, especially in the context of higher education space. Pediatrician, child, that means means child. It's a Latin word called paidos. So that's how it is. You know, gyna and andro are the Greek words for adults. Gyna means women, gynecology, you might have heard this word. Andro means man. English didn't have a neutral general word, so they took andro and converted into andragogy. Okay, gogi means to lead. Agos is to lead something in Latin. So you can understand the difference that learners are independent. Adult learners are independent. And they are learner driven, teacher controlled or directed. Increasing to improve my performance, I want to shine better in my life. And that is why you do. And motivation is purely internal. Nobody is there to motivate. And you want to be, the teacher's role is more of a collaborator role. This is what is andragogy all about. There are many things that you can learn. I just wanted to give it in a nutshell that adult learners are a little different breed altogether. So we cannot use the school learning principles anywhere in the adult learning processes. Okay. There are 7 principles which generally guide. Adults generally have an idea about needing to know certain things, and they determine how they want to learn. Whether I should go to the class and learn, I want to learn it via simulation emulations, or I want to choose my programs. Nobody should direct me, correct? That's what the adults are all about. And practical learning that applies to their life. So all the activities that we want to do, we want to connect it to their lives, how it implies into their life. That's why the previous speaker was also talking about case studies which apply to real life situations. And drawing from past experiences, because adults come with a lot of experience from the rest of the world, and they want to draw conclusions about what they already know to what they are going to learn. And they want to learn by doing it. They don't want to just hear lectures like what I'm doing right now, correct? They want to practice, do certain things. And they are very ready to learn provided they get the right environment to do so. And they themselves are motivated. It's not that somebody has to motivate them to learn. Now what we have done, we have put them into types of courses. Like student needs to learn a couple of arts programs, mathematics courses. Only with maths they can learn humanities, science, technology, engineering, medicine, as the case may be. Okay. And for every course, whatever course has been getting designed, every course shall have some knowledge components, skill components, ability components, attitude components. That means how well can I do? That's why the teamwork and working in teams, all those things come into existence. Then we are also aiming at competency. Because if you look at Bologna Convention and Washington Accord, they are only talking about skilling. In other words, during that time frame, even ABET standards, you take any accreditation standards, they were only talking about skilling. So let us first understand what these things means. We want people to have competence and expertise. Industry is looking for competent engineers and not just skilled engineers. Gone are the days they are just looking for skilled engineers. Knowledge to understand, to apply, which we all know. Skill to proficiency to mastery. Skill itself means progressive practice gets you to skill. Okay, repeated practice is just repetition. Progressive practice is skill. When you get skill, then you have to be mastering. Competency is knowledge, skills and abilities and with attitudes. And this is exactly what CDIO is telling you to incorporate into the curricula, that there should be elements that determine abilities and attitudes. Now capability is multiple competencies with adaptability, and expertise is deeper knowledge, advanced skills and an experience. So how much of what can we produce in each of those courses that we are designing determines your curricula's strength. So curricula can be designed weekly, curricula can be designed in strength. If you want to have a curricula which can you can ensure that the student can get some level of, not just skill, a little more competency, then you are upbeat. So in order to do that, what we have done is that some of the things we directly took it into technology. For example, our university has a more number of courses in the IT sector. As most of you know, India is more of an IT giants, IT, you ask anybody, they'll say, I want to go into IT. Somehow that craze has got into the stream. So we have to get them skilled and competent. Correct? Now what happens? Somebody from India comes, it is assumed by the industry that that fellow is competent in coding. We only know the real facts and figures. Am I right? Now how do we make them competent? Progressive practice is competency. So what we did is that we created a couple of learning tools which will help them to do so. So I'll invite my colleague to quickly demonstrate 4 or 5 tools, each tool to 2 to 5 minutes, and we'll close the session. Yes. You can sit here.
Okay, fine. So thank you for that elaboration. I think I will be sharing about how did we implement this CDIO in our campus. I'm not talking about the I in the CDIO. I will be talking about small I. How did we implement this in our SRM campus? And first of all, I would like to thank China. We are fortunate for China because we have completely displaced China to become the #1 populated country in the world. Yes. Yeah. So thankful to China.
So some production is happening.
Yeah. At the back end. At the back. Okay.
High productivity is happening.
Okay. Humors apart, but you can see we have around 140 billion population across India, and you can see that. Okay, jokes apart, but still, you can see the monitoring of students' performance becomes a big task for us. Okay.
As teachers.
As a teachers, see in our campus alone, if you have seen the video, we have around 60,000 students in our campus, in one campus. So how do we implement all this stuff into our stick? What we did is we have developed an in-house learning management systems and the portals, which we are going to show now. Now, the first tool we are talking about is the coding practices. Like, like Professor Rajeev said, everyone in India will be so crazy about the IT industries. No, you call even a labor or even a layman, they will say, I want to learn any programming or web technology for the matter. So what we did is we created a programming course. I believe these are the list of programming courses. It's getting loading. List. Yeah, it is getting loaded. Yeah. Have a Wi-Fi?
Wi-Fi got disconnected.
The hotspot. Yeah. Yeah, I got it. Student line. Yeah. Slow. Yeah, credentials so far.
No, I don't have hotspot. Connect to Polibatam instead of CDIO. No. Just other networks. Go to other networks and connect only to Polibatam.
Okay.
Network. Yeah.
Got it. Yeah, got it. I got it. Yeah, finally. So these are the set of programming courses. We have Python, data structures, analysis of algorithms, C++, C#, Perl, Ruby, Go, Octave.
Lua,
So these are the
Haskell, R, Julia. How many of these programming languages are there? Each one has certain different purposes. Some are functional programming languages, some are object-oriented languages. See, different industries have different requirements based on their projects. So we want in the first year the students to get skilled on those things. So whatever is the language that they want to study, we have a tool for that. And can you just go into practice? We'll just explain it quickly. Yeah. So any course you take, there are topics. Under those topics, there are 3 circles. The first circle is all bookish level programming exercises, but it's all scenario based, case based. The second level is a little more difficult programming exercises, and third. So if you look at every circle, there are 100. A student in his regular course to get skilled does 300 problems to solve. 24/7, this is live. And there are small nuggets of activities where they have to go, understand the scenario, solve it. For example, there is a problem description and a requirement. And they have to understand the description. So they are all real-time scenarios, small snippets of real-time scenarios. How do I address this problem? The very purpose of making them go through this rigorous exercise is to develop logical and mathematical intelligence in their brains. I repeat again, programming is just an excuse to develop logical and mathological intelligence in their brain. Because as we all know in India, when they study in schools, it's more of a routine curriculum. So here they have to go and explore. And once they go into, say, the teacher will say that, you do 200 programs, 300 programs, as you wish. Okay, the more the better, because the better is your logical abilities. And evaluation system is also like this. Now, how does these questions come? We have a huge repository of 5,000, 6,000 case studies at the back end. So it randomly picks and gives you, based on the levels of difficulty, it randomly picks it. So no two students will perhaps get the same problem. Otherwise, one will solve and the other will copy. So we know what our students will do. Immediately, yes. So that's what has happened. So we want to shed that. So it comes from a pool of data, and henceforth it is much easier to do. So these are online compilers. They read the problem, they solve it there itself with a couple of test cases to check. So there's an auto evaluation tool, auto evaluating compiler tools. They can do it on their own and keep moving further. Obviously, there are assessments in between. Suddenly the teacher will say, okay, you have written this code, fantastic, now delete the code and do it in front of me. That's all. Correct? You have done the code. Yes, I have done the code. Very good. Delete it in front of me. Do it once again. That's all. You verify whether he has done it or somebody else has done it or outsourced it. In India, we also outsource, no? Students are outsourcing it much better. Across the globe, they are outsourcing. Now, thanks to ChatGPT and other AI tools, they are outsourcing to AI tools as well. Yes.
Now it's crowdsourcing.
Crowdsourcing. Yes.
Yeah.
So what is the need of understanding this? Because as we go into a AI generation, AI generates a code. I want to slightly modify it. If I don't know what code it is, how will I modify? Like somebody answered, why don't I rewrite the prompt with that modification and give it once again? Of course, it will again give you a code. I want to alter it, understand it. What do? If I don't have that logical abilities to understand the code, then obviously you are in trouble, especially if you are in the IT sector. So you have to know to code and use AI as your assistant to code it, and then you modify it, alter it, improve it, whatever. Yeah, so can we go?
Like, how do we monitor students for capstone project?
So on the back end, what happens? The teacher can monitor the complete student progress, what the teacher is doing. So we all know that if the teacher is monitoring things, it's much easier for the teacher to identify who is actually coding, how many times he has logged in, when he is logging in, when he is logging out, did he really do it, from which school he is. So he is actually showing, can you show the live statistics, how many people are there live as of now? Is it possible?
That's it.
Yeah.
Let me check it out.
Okay.
Now this is an the report part from the administrator. As we told you that how do we choose students for this capstone project, any real-time project? So this is an software which will around as Professor rightly said, there will be 6,000 questions or 6,000 case studies. Few will be easy and few will be tough, a real-time scenario. Now, how do we segregate students around this? That around those 6,000, students will be getting around 300 test cases or 300 case studies. In that 300 case studies, there will be around 15 to 20 real-time scenarios, real-time case problems, like we mentioned as we seen in the last session. So what we do is at the back end, as administrator, we get the students detail like this, and it shows that he has completed 300 programs. So he tops the list. Then if I go to this, his login, I can able to see
what the student has done, where he is stuck, where he is not stuck.
Yeah.
So the mantra is that everything was read earlier.
Yeah.
Mantra is go green.
That's why we are wearing green
Make
shirt.
everything green.
That's why we are wearing green shirt now. Green batik shirt.
Go green.
Good. So now, based on this, what we do is we'll identify students, their departments, their program, and we'll send this list to the capstone project team, robotics team, and they will have an MOU with other institutes, other universities, and get the things done. So this is how we monitor students in India, at least perhaps in our university. Next.
Can you just move to the next? E-curricula is a typically learning management system with a lot of AI support at the back end. Okay. In terms of creating materials, teachers use AI. In terms of creating assessments, teachers use AI. I don't want to elaborate too much on AI because most of you know how to use AI, correct? But how is it helpful for the teachers? I mean, for the, can you just click on? Yeah, yeah. We'll close at 3:30, 3:20. Okay, fine. So most of our classes are in sessions. That means either it's a laboratory session or a theory session. It's a session. So once you go into the session, every session has a very defined by the teacher learning rationale, learning outcome, and a learning plan. How that 50 minutes or 1 hour is going to be conducted. Then
And the CDIO thing.
and it is also every session is mapped with CDIO. Every session is mapped with CDIO
Of all courses.
of all courses. And then there is a learning content. Can you carry on? Yeah. Learning content which the student can watch it, download it, alter it, modify it, whatever he wants to. This is the teacher provided minimum learning material. Okay, sometimes even students do idiotic things. That's why the teacher is color coded what to multiply, what not to multiply. Correct? Otherwise they multiply it wrongly and you know what all errors will come. And every session's content, we also have a lot of videos. So I miss the class, what do I do?
Find the characteristic equation of matrix.
So mostly scribe videos because this is a course on mathematics. So it's a sequential,
Let A equals
procedural knowledge course. So it has to go in a sequence.
matrix. Step two.
Slightly forward.
Elements of A
Okay, can you just
is
mute it?
equal to 1 plus.
Now what can a teacher do? Teacher can mute it, play it, and the teacher can speak in the class. Yes? Step by step, he can go previous page. You know, when I used to teach electromagnetics, quite funny it was. That time with chalk and, markers. I write the first board, then I erase it. The second board, erase it. Third board, halfway I'll say, previous board, alpha value substituted here. Who remembers? Here you can scroll back. So, and most of our students, we know before the exams, they want to study. Am I right? Or they study daily. I don't know. So they can always go through all the videos and rewind these sessions. So if you have captured most of the contents, you don't have much trouble about. Can you just quickly show e-curricula and then come back? Yeah. And 10 minutes class over, immediately do an assessment. So the instruction is very simple. Teacher has to say, take your learning devices. This is a learning device, right? The teacher will say, take your learning devices, do the assessment. They'll finish the assessment. And you can see the statistics, who has done what. Within no time, the teacher gets a feedback of what you have lectured for the last 10 minutes. So it is more of an interactive session. So he's showing a typical mathematics, very dry classroom, made highly interactive. And from the material, you can take them to GeoGebra. Contents are there, algebra contents are there. Yeah, just go to the session and let us show one more. Even classroom materials are directly interfaced with the necessary tools. Where is a see, this is a diagonalization of a matrix. And you can directly from your material, you can go to, yeah, click on it. It will directly take you to GeoGebra where you can actually see, why it's not loading. So you can visually give an impact from your content. Okay, it's not getting loaded. Okay, it's not getting loaded. E-circuit. That's okay. Just
Max calculator.
yeah. Okay, they straight away go into any of those learning tools and explain the class. So we hardly use MATLAB, we use Scilab. So from the mathematics course, we have a direct link to Scilab where they can go and do your rest of your stuff there, because this is a course which contains.
We have 244 courses in engineering.
Yeah.
Out
That's
of
okay.
which, yeah, 33%.
Go to e-curriculum. So time is up. So we'll have to speed up.
Circuit.
Circuit, minimize. Circuit simulation in a classroom, you can do with animations, graphics, etc. and teach the course without much of an effort. So a lot of pre-built circuits have been made. You can alter, modify. See, nothing is going to burn here, right? So let the student play along with this, get himself thorough. Then you take them to the practice element in the laboratory, let him build. So make them simulate, emulate, play around. Because see, the actual laboratory equipments don't come to your home, but the simulation emulations will come to your home. They are 24/7 live. You can play around any number of times and then you can use them to your advantage. Okay. Create a lot of pre-built circuits, feed them inside, let them play around. Fundamental electronics, electrical, analog electronics, linear integrated circuits, basics of communication. So these are some of the microprocessor tools, toolbox. Fully online in our university. So best practices, best simulation. For example, the circuit simulation I showed you was from a professor in Spain. I requested the professor, he shared the code, we integrated it into our learning management system and put it there. So you have to just look a little wider and understand what is needed for your learners to learn better. And most of these tools are all suggested by the faculty members who teach the programs, teach those courses. Can you just show one, what you call, a microprocessor or something like that? This is a coder for your microprocessor. I'm sorry. We are planning to open. Because most of these things, see, across the world, certain things are very fundamental. We can always open it. Something is very, very specific to an institution. You have to customize it, obviously. I think we have done enough. One 2D CAD, 3D CAD, everything can work on the web. See, the idea is that everything can work open on 2D CAD and 2D CAD or 3D CAD. So even mechanical design. During pandemic, what happened? No, we had these AutoCAD and other paid software licenses tied up to a machine which had a hardware lock and all. But unfortunately, the machine doesn't come to your home. You are at home during pandemic. You can't go to the college laboratory facility. Then what do you do? At least you have to learn 2D CAD, everything you can do sitting at home. That is the advantage. When you have simulation, emulation, technology support, certain things you can always do at home. Not 100% everything you can do, but still you can practice quite a lot of things at home. Everything accessed via web. So servers were live during pandemic. Students were studying from home, but they didn't touch the actual machinery. After the pandemic only, they could come and touch the actual machinery. So that was a challenge. Otherwise, we could easily, seamlessly move from one platform to another. I think with this, we will close the session. Say that we have created our own, See, this is like a Google Play Store. We have created our own Play Store for the teachers and students to play along with. Whatever they want to do, they can always open it and start doing things. I think with this, we'll close the session. And if there are any questions, we'll take those questions. And let us see how we can collaborate, cooperate, and take things further. Is it too much? Yes. I'm sorry. See, that's a huge challenge. Right now, in this educational policy that I'm showing was prescribed by the government in 2020. So rarely we have had exit, except for one or two very genuine cases where father is the only earning money, father died, mother cannot pay the fees, so I have to go and work. You know, only very rare one or two cases have happened where they have left the organization. Still today we have not had a case where somebody from the organization has come back to study. So far we have not had a case like that. That facility is built into the system so that even if due to some reason somebody drops out, they can always come back. During that time, the number of seats that you are talking about, if it is huge in numbers, I don't know how we have to address that, but one or two is always easy to accommodate into the system. That's not a challenge actually. Any other questions that you have in mind? Yeah. Self-developed. They were self-developed by our team. No, these are all, this is WebCAD, which is already available in the internet. I requested WebCAD to share the code so that we can host it into our servers. Why? Because WebCAD suddenly is under maintenance or something like that. And I cannot direct my student to go to that website, this website. Once he goes there, then from there he gets diverted and keeps on going. Am I right? So I have to somehow pull even the YouTube video he was showing is a private YouTube channel which will play inside the screen. If you go to YouTube, he will see some other thing and then you will go from there to there to there, you know, you lose focus. We know what happens, right? We ourselves do that. Yeah, so you have to keep them intact during the learning hours. Evening, let him do whatever he wants. But during the learning hour, I cannot distract him or divert them. I have to keep them on focus. So that's why the teachers find it very helpful when they have these contents. And these contents are all being created by a team of faculty, well curated, audited, checklisted, quality checklisted, then hosted. You know, if both of us are teaching the same course, we will ourselves have some disagreements. But if we both collaboratively create the material, all those disagreements are sorted out upfront. Correct? So the material comes with much more quality, standardization, etc. Why do we want to create this is because just because I was sick for 5 days with fever and I missed classes and I don't know what happened in the classes, so I can always play the video again, learn it myself. If I have any doubt, I can always say that, okay, in flip learning mode, I have learned it, but I have these doubts. You can always ask the faculty member. So we are always there to help our learners, right? Yes. I think with this we will close. I know it's time. With this we'll close the session. If you have more queries during tea break, we can address them.
Thank you.
Okay, he has written a HTML code in the online compile editor to show. Thank you. Thank you. Bye bye.
Okay, thank you. Thank you very much. Okay, the next session is tea break. So we come back to the auditorium. So now we come back to the auditorium, and after the tea break, we get the roundtable session. Okay, thank you for your attention. Good afternoon.